My friends told me that my online persona should be Mathy Matt, so this is Mathy Matt here to talk to you about some informal area strategies. I'm going to look at shape A and show 3 different strategies that are common for how to think about the area of this shape, and then we'll do one other shape with one of these strategies. So shape A was a triangle, it looked like this. And we're going to try to figure out the area of this shape. So I can start to count some of the squares. It's got one full square, it's got a second full square, and I'd like to count this third full square, but it's missing this little piece right here in the top left corner. So what I'm going to do is I see a kind of matching piece right above it, and I'm just going to rotate that into position so I now have a full square. Similarly, I want to count this next square as a 4th square, but it's missing quite a bit. Right above it, but I can find a matching piece here and I can kind of rotate that into position. And then finally I'd like to count this top right square as 5. It's also missing a piece, but I can find a matching piece and move that into position. This is one common way to figure out that there's 5 squares inside this triangle. Now, not everyone who does this thinks of actually moving the pieces. They might more just think of the sort of compensating or making up for the missing piece, the missing parts of the whole squares. All right, let's look at a separate second strategy. It's very similar, except instead of moving every little single piece, we're going to move a whole chunk at once. So I've got my triangle, and I'm going to go ahead and cut it right here, and I'm going to move that whole thing like this. And then I've got a nice shape that's really easy for me to work with. So I can count 1 square, 2 squares, 3 squares, 4 squares, and then altogether this is a 5th square over here. And that makes it a lot easier for me to count by turning it into a rectangle. All right, I'm going to show you the third strategy, which is subtraction, but then I'll show it to you again with a more complicated shape. So again, here's our triangle, and I can think of this triangle as being inside a rectangle. And we're actually going to use this idea a lot in the next video also, of putting things inside of rectangles. When it's inside of a rectangle, it's really easy for me to count the area. I can see that I have 10 squares inside this rectangle. But my triangle is only half of that rectangle, so I do 10 divided by 2, and I get my 5 squares inside the triangle. All right, let's talk about what that strategy looks like with shape G. Shape G looks like this. We can think of putting it inside a rectangle like this, and then we want to subtract off these pieces we don't need. So I've got this right triangle here. I can get rid of that, and I already know from some of my strategies before that it's half of this little rectangle. I've got another right triangle here in green, and it's half of this rectangle. Similarly, I could subtract off this red triangle and this blue triangle. And after I subtracted off all those triangles, I'd be left with my overall area. All right, so what you're going to be asked to do next is reflect on how what you saw in this video relates to the strategies you used on this worksheet and how these strategies would apply to some of the other shapes on the worksheet.